Hi students, this video is looking at how to use trigonometry to solve problems involving angles of elevation and depression. Alright, so after watching this video you should be able to apply your understanding of trigonometry to solve problems involving angles of elevation and depression. So a few things to remember. Remembering the sides of your right angle triangle with any trigonometry problem, being able to label your sides, hypotenuse, adjacent, next to our angle, and opposite, along with remembering our sine, cos and tan formulas is going to be very important. It's also worth knowing from previous lessons how to calculate unknown sides and unknown angles of right angle triangles. Right, now first of all a definition. So angles of elevation and depression are always used to basically help us work out heights and distances in some sort of geometric sense. So a surveyor might use them to help work out how far the land is rising or falling, or how tall a building is. That's the sort of application we're talking about here. Now the key thing to know is angles of elevation and depression are always measured to the horizontal. So in here, in our first one, we've got a person, there's our horizontal looking straight across, and the angle of elevation is how far they need to look up by to see the object that they're looking at. So that's our angle of elevation. Our angle of depression, again, is from that horizontal line downwards. And so that one there is our angle of depression. Now, the most common mistake we see when talking about an angle of depression is students often think that it's the angle in here to the vertical, but that is not right. Never right. The angle of depression, just like the angle of elevation, is always to a horizontal line like this one here. Always to a horizontal line. Now, this fact is important because it means that the angles are actually alternate. So our angle of depression up here from one object to another object, that angle of depression, according to our Z rule, is equal to the angle of elevation from that second object, or that second person, up to the first. So the angle of elevation, of depression, sorry, from the first person to the second, is going to be equal to the angle of elevation from the second person to the first, because of that Z rule, because those angles are alternate. And that's why it's really important that both our angles of elevation and depression are always to the horizontal. Right, so let's apply this to a problem. So we've got a person standing 34.1 meters from the base of a building. To see the top, that person has to look upwards at an angle of 28.5 degrees. Calculate the height of the building. Alright, so our first step with any trigonometry problem is always to try and draw a picture. Now we know for trigonometry that we are dealing with triangles, and most of the time we're going to be dealing with right angle triangles. So here, let's say we've got our building. Our buildings usually go straight upwards. Let's assume this one does, but we don't know how high it is. And then we've along the ground, about 34 meters away, 34.1 meters away, we've got our person who is going to be looking up at the top of our tower. And the angle that they're looking up at here is going to be 28.5 degrees. So we've got our building, which I'll label here. We've got the ground 34.1 meters away for our person, and they're looking up at an angle of 28.5 degrees at the very top of the building. And they have to work out, all right, how tall is our building? Now with any trigonometry problem, our first step, we could assume our building goes straight upwards too, making a right angle with the ground. What we have to do first with any trig problem is label our sides. So we've got our hypotenuse there, which is the longest. We've got our adjacent along the ground and our opposite over here. With O and A, we're going to be using tan. So we've got tan of our angle equals opposite over adjacent, and we can start substituting our values in. The tan of our angle, which is 28.5 degrees, equals our opposite, which is x, over our adjacent, which is 31.4 meters, so 34.1 meters. And then just to rearrange that, we'll times both sides by 34.1, meaning those get to cancel each other out. And we're left with 34.1 times tan, 28.5 degrees, equals x, which is equal to 18.51 meters. Writing our sentence to explain our answer to the original question. The building is 18.51 meters tall. And there's our angle of elevation problem done. The key step there, students, is making sure you can draw your right angle triangle and include all of the information you've got there from the question. All right, doing another example, we've got a person standing on a cliff that is 17.2 meters high. The person sees the boat at an angle of depression of 38.8 degrees. Now I have to calculate the distance between the boat and the base of the cliff. So once again, we'll draw our diagram. Let's say there's our cliff with our person at the very top. Now they're looking across the water, nice flat water, at our boat, and they're looking down at an angle of depression of 38.8 degrees. Now we know, as we've seen with our alternate angles, that this angle down here, according to our Z rule, must also be 38.8 degrees. And then the height of our cliff, which we're told as well, is 17.2 meters. Now the question asks us to work out the distance between the boat and the base of the cliff. The base of the cliff is here at the very bottom of our cliff, so we're looking for this distance here. Alright, so now let's label our sides. The long side there is the hypotenuse. The adjacent side is along the water. The opposite side is our cliff. So once again, O and A, we're going to use tan. So tan of our angle equals opposite over adjacent. So tan of 38.8 degrees equals our opposite, which is 17.2 over x. And then just rearranging that, multiplying both sides by x. X tan 38.8 equals 17.2. Let's show the working out there. X's and x's cancel. And then to get x on its own, we're going to divide by tan 38.8 because we've got multiplication in there. So the opposite of multiplying by tan 38.8 is dividing by tan 38.8. Those cancel. So x is going to equal 17.2 divided by tan 38.8, which equals 21.39 meters. So we can say the boat is 21.39 meters from the base of the cliff. Key thing with that one, students, is again making sure you draw your diagram, but also recognizing that we can use alternate angles to turn this into a triangle problem that we can easily solve. Alright, so after watching this video, you should be able to apply your understanding of trigonometry to solve problems involving angles of elevation and angles of depression.